Europe just received a major wake-up call. A fresh Polaris Market Research report confirms that AI in manufacturing is not a slow trend. It is a full-scale transformation with a market jump from, get this, USD 1.30 billion in 2024 to USD 56.40 billion by 2034. That's at a wild 45.9% CAGR. This is not hype. This is Europe's factories being rebuilt for an AI-first decade. But before we dive in, did you know 40% of you listening aren't following us? Come on, mates, hit that follow button and collect our episodes on pods.media. Your support keeps the show going. Thanks, guys.
Okay, let's unpack this. When you see a number like 45.9%, I mean, a compound annual growth rate like that over 10 years, we're not discussing marginal improvements. We are discussing the total, the immediate obsolescence of traditional and flexible automation. This is Europe's shift to intelligent, data-driven, self-optimizing production. It feels like it's being forced by both policy and necessity.
The gravity of those numbers really can't be overstated. And what's driving this is a foundational push from multiple angles. We can see four primary sort of interconnected accelerators here. First, you've got the crucial EU digital policies, things like the upcoming AI Act and this ongoing push for data sovereignty, which are basically forcing industrial digitalization on a timeline.
So policy is the hammer, but what about the foundation? What's it being built on?
That's where the second driver comes in. It's the widespread adoption of Industry 4.0 standards.
Mm-hmm.
You see, Europe had the groundwork laid with I 4.0 for years.
Mm-hmm.
Now, AI is providing the, let's call it the cognitive layer, to make those connected systems truly smart.
Right.
Third is falling technology costs.
Yeah.
I mean, cloud services, specialized hardware, standardized AI models, all of this has made really sophisticated tools accessible. And finally, and this is crucial, the surge of small and medium enterprises, the SMEs, integrating these AI tools. That really validates the sheer breadth of this transformation. It's not just the giants like Siemens or Bosch anymore.
That's a powerful cocktail of drivers. But I think a lot of people hear $56 billion market growth and immediately assume that just means soaring software subscription revenue. What does the practical reality of this explosive growth look like, on the factory floor right now? Where is the investment capital actually landing first?
Well, what's particularly fascinating is that the current leading market segment isn't the AI algorithms themselves. It's actually hardware. Manufacturers are heavily, and I mean heavily, installing AI-capable machinery, edge devices, sensor networks. They are laying the physical data collection foundation that the algorithms need to learn from.
But wait, hang on. If this is an AI revolution, why isn't the software leading the spending? Does that focus on hardware signal, skepticism about the AI itself, or is it just necessary groundwork?
It's absolutely necessary groundwork. Think about it. AI needs massive volumes of clean, real-time data to function well. Most older factory floors are, frankly, data-poor environments. You just can't implement advanced predictive maintenance or complex computer vision without hundreds of thousands of new, sophisticated sensors. And you need the computing power, the edge devices, to process that data locally. So the hardware investment, it signals a real commitment to building a data architecture that can support enterprise-level intelligence.
That makes perfect sense. The ability to collect and process data locally right at the edge, that's what accelerates real-time adaptation. Okay, let's go under the hood then. If you're tracking this transformation, what are the, 5 core technological components driving this that you should be focusing on? What actually defines an AI-ready factory?
We can break the smart factory down into 5 essential, and they are highly interdependent pillars. First up, machine learning. And this goes far beyond basic statistical models. In manufacturing, it's about deploying custom models for demand forecasting, for dynamic resource optimization, and for decision support. It's teaching systems to adapt production schedules in real time based on, fluctuating energy prices or unexpected material delays.
And the visual side of that intelligence, how does that fit in?
That's the second pillar, computer vision, or CV. This is mission-critical in high-precision European industries. We're talking about using deep learning models on the assembly line to achieve sub-millimeter precision inspection at really high speeds. It's vital for instant defect detection, ensuring 100% component traceability, and automatically confirming compliance with these incredibly strict standards without a human having to intervene. And that capability is often heavily reliant on the edge hardware we just talked about.
Of course, it all connects.
The third is predictive maintenance. Now, the concept is simple, predicting failure, but the industrial execution is complex. It involves integrating vibration analysis, thermal imaging, acoustic data, pressure readings, all across these massive, often decades-old factory environments to maximize asset uptime. I'd say reducing unexpected downtime is probably the most immediate financial win for manufacturers adopting AI.
I can believe that. What's number 4?
Fourth is advanced robotics and automated material handling. These systems are moving past simple repetition. They're being guided by smarter AI protocols using things like reinforcement learning to optimize pathing, grasp strength, and speed. That makes them far more flexible and adaptable to varying product mixes.
And the 5th pillar.
And finally, digital twins. This is where the simulation environment meets reality. A digital twin isn't just a 3D model. It's a living, real-time virtual replica fed by thousands of physical sensors. This lets production managers test changes, a new material, a workflow adjustment, a supply chain shock in a virtual world before risking a costly physical deployment. It's the ultimate tool for strategic planning and rapid iteration.
That closed-loop sensors feeding the digital twin, which then informs the predictive maintenance and the ML optimization, that's the signature of a self-optimizing system. But let's zoom back out to the SMEs. Historically, they've been pretty cautious adopters. How are they deploying these complex systems at scale? I mean, that really validates the continental breadth of this $56 billion transformation, right?
Their adoption is only possible because of targeted, very practical support mechanisms. We are seeing a massive proliferation of these digital innovation hubs, often backed by national or EU funding. These hubs, they de-risk the initial adoption for SMEs. They provide access to low-cost, standardized AI toolkits. They offer subsidized pilot projects, and, crucially, they deliver the necessary training. It just removes that paralyzing fear of astronomical upfront costs and technological complexity.
And if we connect that adoption strategy to the broader European context, the scientific rigor, how does the academic environment play into this rapid transition?
Oh, it's a direct pipeline. Europe maintains some of the world's strongest academic and research environments, particularly in robotics and machine learning. Look at the clusters in Germany, which is a global leader in industrial automation, or the Netherlands, which excels in high-tech systems. EU-funded projects are increasingly mandate-driven, requiring that research innovations be pushed quickly and efficiently into real industrial use cases. That just drastically shortens the traditional time to market, from the lab to the factory floor.
Okay, here's where it gets really interesting on the global stage. This isn't just an internal European story. This modernization effort, it changes global competitive dynamics. What are the global ramifications of Europe's AI factory ascent?
Well, when a major high-cost industrial bloc modernizes at this speed, it completely resets global standards. First, we see product life cycles shrinking because the speed of R&D and rapid prototyping allowed by digital twins is just unprecedented. Second, quality standards inevitably skyrocket because AI vision systems don't experience human error or fatigue.
And what about addressing the supply chain instability that has plagued the industry for years?
AI provides dynamic resiliency. Supply chains become far more robust through advanced forecasting and dynamic autonomous routing optimization. But the biggest geographical shift is the acceleration of nearshoring. By making European production cheaper, faster, and more efficient through AI, manufacturers can afford to move production closer to their consumers across the EU. This significantly reduces lead times and logistics risk, making European industries dramatically more competitive globally against low-cost manufacturing centers.
And that competitiveness ties directly to sustainability, which is a core European regulatory goal, isn't it?
Absolutely. The beauty of AI in manufacturing is that efficiency is, it's inextricably linked to sustainability, optimized production schedules, reduced waste from real-time defect detection, precise energy management. It all means manufacturers can demonstrably reduce emissions and resource consumption while simultaneously increasing their output. AI becomes a necessary tool for meeting those stringent green mandates.
So who is currently leading the charge within Europe? Let's look at the national powerhouses pulling ahead in this $56 billion market race.
Germany, to no one's surprise, is the anchor. It dominates the current market share, largely because it is the heart of Industry 4.0 and home to automotive giants and massive, highly complex machinery sectors. Their focus is capital-intensive. Huge investment in AI-driven hardware installation and pioneering large-scale predictive maintenance programs.
Right. And who's next?
Next is the United Kingdom, which is growing exceptionally fast. This is partly driven by competitive pressure post-Brexit and accelerated by national schemes like Made Smarter. Their AI adoption is highly concentrated in high-value, high-compliance sectors. Aerospace, demanding pharmaceutical manufacturing, and complex food processing.
Then you have France, which has a very specific policy-driven strategy.
Correct. France is heavily driven by its France 2030 initiative. Their focus is specifically on low-carbon, AI-enhanced, energy-efficient factories. They are really integrating AI to build the next generation of industrial sustainability champions.
And the Netherlands.
Finally, we have to recognize the Netherlands. They're setting the pace through advanced digital infrastructure, exceptional robotics clusters, and a strong export focus on high-tech systems. They are leaders in sophisticated digital twin deployment and cross-sector integration.
It's clear that existing industrial strength dictates where the national focus lands, but nations rely on their ecosystem. We should probably acknowledge the key companies building the industrial backbone that enable this rapid transformation. This is a massive piece of that $56 billion projection.
It is, and we can sort of separate them into two essential groups for you. First, the infrastructure and software giants. These are the companies enabling the foundational data movement and computing power. You have legacy industrial players like Siemens, who integrate IT with operational technology, enterprise software leaders like SAP and Bosch, and then the critical foundational technology providers, Microsoft, IBM, and Google for cloud platforms, and crucially, NVIDIA, which provides the GPU computing necessary for training and deploying these complex AI models.
Both in the cloud and at the edge, I'd imagine. And the second group, the application layer.
That's where the specialized AI developers come in, the companies delivering the cutting-edge application layers directly to the factory floor. Think Oracle, which provides specialized data architecture for manufacturing, Sight Machine for factory data operations, Spark Cognition for predictive analytics, and specialized robotics firms like Rethink Robotics. This second group is turning that raw compute power into functional, deployed AI solutions.
This momentum is undeniable, but a transition of this magnitude is never smooth. So this raises an important question. What are the significant challenges ahead? The transformation won't happen without turbulence, particularly for that crucial SME segment.
The obstacles are profoundly difficult, yes. The first challenge remains high integration costs. While technology costs are dropping, the expense of ripping out and replacing legacy infrastructure or retrofitting older machines with sensors, it's a massive upfront investment that SMEs often just can't easily absorb. Second, we face the problem of data maturity. Many European factories are sitting on decades of highly inconsistent data silos, messy workflows, and proprietary, incompatible industrial systems. You can't run sophisticated machine learning on messy data. That prerequisite work of standardizing data architecture and cleaning those workflows, it significantly slows down the speed of AI deployment.
And that complexity inevitably strains the human side of the equation.
Precisely. The skills gap is widening dramatically. The demand for AI fluency, whether it's for maintenance engineers who need to manage predictive models or production planners who must use digital twins, is rising much faster than the supply of qualified workers. This creates a real bottleneck on deployment speed.
And I suppose regulation is a double-edged sword?
It can be. While the policies are driving investment, they also impose significant compliance burdens, particularly in sensitive sectors like aerospace and pharmaceuticals. Integrating AI solutions that meet new EU data and safety standards adds layers of time and cost to every single deployment.
So the factory of the future is ready to be built, but we have to deal with the operational debt of the factory of the past first. If Europe manages to navigate these hurdles, let's look toward that 2034 future outlook. If this market truly hits that $56.4 billion projection, what does the average European manufacturing landscape look like?
By 2034, we expect reactive manual planning to be virtually obsolete. AI-enhanced autonomous production planning will be the universal standard. That means systems reacting instantly to global events. Predictive maintenance will have evolved from a competitive advantage to just a baseline operational necessity, slashing downtime almost universally across all major sectors. Crucially, digital twins will be ubiquitous. They'll serve as the central nervous system for real-time, high-stakes decision-making. The intelligence gap between large enterprises and SMEs will shrink drastically, with smaller operations benefiting from enterprise-level data capabilities.
And the investment shift we noted at the start, the lead of hardware will have matured by then.
Yes. The initial hardware investments will accelerate and then transition into software optimization and specialized AI services across key regional clusters, especially Germany, France, and Italy. And finally, that nearshoring trend will solidify. Manufacturing operations will be structurally decentralized and closer to consumption points across Europe, creating highly resilient regional supply chains, all driven by AI-enabled logistics.
That's the big picture analysis. This is not merely an investment cycle. This is the biggest fundamental industrial shift Europe has seen since the widespread adoption of automation decades ago. That $56.4 billion projection is the clear signal. Without comprehensive AI integration, competition becomes impossible. Not on quality, not on speed, not on costs, and certainly not on sustainability.
And if we connect this back to the core source takeaway, it's vital to stress this. AI will not replace European manufacturing jobs. It will rebuild the processes and the factories themselves. The companies that adopt early and adapt fastest, tackling the deep integration and skills challenges now, are the ones that will define the industrial landscape and become the undisputed global winners.
A final provocative thought for you to consider based on the report's structure. We discussed how hardware investment is currently leading the market because of the need to install sensors and edge computing for real-time data collection. Given this foundational push, which industries in the UK, beyond the already mentioned aerospace and pharma, are most likely to see the largest hardware AI capital expenditures next year, think about which sectors have the most complex physical assets, or maybe the oldest infrastructure that desperately needs modern sensing. Something to explore on your own. Thanks for diving in with us. We'll catch you next time on The Deep Dive.